What's up, everybody? This is John with John Fair Innovations, bringing you another math lesson. And today I'm going to be teaching you about scientific notation and how to convert between scientific notation and regular numbering systems. Now, before I get to the video, if you enjoy that, do make sure you hit that like button, leave a comment on maybe another math topic you'd like me to tackle. And if you really enjoy the video, do make sure you hit that subscribe button so you can stay up to date with all the videos. And it really does help out the channel. So if you've done so already, thank you so much for your support. Now, today we're going to be dealing with scientific notation. And all scientific notation is when we take really, really large numbers or really, really small numbers and we sort of simplify them a bit to make it a bit easier when dealing with calculations. Now, it's important to note with scientific notation, we're dealing with the concept of powers of 10. And what we mean by that is we're either increasing or decreasing by a factor of 10. So let's first deal with positive power ofs. So let's say if we have 5 times 10 to the power of 0, well, 10 to the power of 0 is the same as 1. So 5 times 10 to the power of 0 would be 5. 5 times 10 to the power of 1 would be 50. 5 times 10 to the power of 2 would be 500. And what this really means is 5 times 1, 5 times 10, 5 times 100, or 5 times 10 times 10. And so you can see that as we increase our positive indice, we're increasing the value of our total. So this is all scientific notation is. This scientific notation is expressing these values in terms of powers of 10, of a factor of 10. Now let's use it in an example of a really, really large number. So let's say we had this one, for example, which is 41,236,000,000. Now, obviously, if we were dealing with calculations, we wouldn't want to have to write this over and over and over again. And also, when you're dealing with scientific notation, those zeros will be treated exactly the same if you factor in the fact that it's going to be the same power factor. So we don't have to necessarily worry about them in calculations. We would still get the same sort of concept. So obviously, we would not want to write that over and over again. So now we've got to look at our values after our very first number. So our very first number is 4. So we look at how many we have after this. So you can see we counted up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 values. And if you want to look at it, what we really do is we take a decimal point and we move it across until we get to our final value. So we can see here we've made 10 jumps. So when we write it, we write 4.1236. So we write all the values that aren't 0. And we have times 10 to the power of how many jumps we made, which in this case was 10. So it'd be 4.1236 times 10 to the power of 10. Now, if you wanted to convert back the other way, so let's say we had something in scientific notation that looked like this. Let's say we had 1.498 times 10 to the power of 4. Well, this time we're jumping across in the other direction. So we're increasing our values. So again, same thing, we keep just jumping across. So we jump 4 times because that's how the power of we've got here, power of 4. And every time we have a value beyond our values that we've got here. So in this case, we've only got 3 values after the decimal point, so we would have one more jump. So every time we do that, we add a 0. So in this case, this one would be the same as 14,980. But let's say we increase that to the power of 6. So we would just increase 2 more jumps. So there would be 2 more zeros. So then that would then become 1,498,000. And again, to check that we've made sure we've got it right, we can see there we've got 6 jumps, we've got 6 value places. So it is 1.498 times 10 to the power of 6, or 1,498,000. But let's now look at what happens when we have a negative indice. So we have a negative power of. Well, again, we're still dealing with the concept of 10. So we're still factoring the concept of 10. So in the past, we had 5 times 10 to the power of 0, which gave us 5. 5 times 10 to the power of 1, which gave us 50, so 5 times 10. And then we had 5 times 10 to the power of 2, which was 500, so 5 times 10 times 10. So as we increase our indice, so increase the value of our indice, we increase the overall total. So the bigger the power of is, the bigger the final number is going to be. So obviously then if we're decreasing, if we're going into the negative, we're going to be dealing with smaller numbers. So if we look at a negative indice, so let's look at 10 to the power of negative 1, that's really the same as 1 divided by 10 to the power of 1, which is 1 divided by 10. 10 to the power of negative 2 is the same as 1 divided by 10 to the power of 2, which is 1 divided by 10 to the power 10 times 10, which is 1 divided by 100. And if we do that again to the power of negative 3, that's the same as 1 divided by 10 times 10 times 10, or 1 divided by 10 to the power of 3, which is the same as 1 divided by 1,000. So this time we're dividing by our indice factor. So if it was 10 to the power of 3, we'd be timesing by 1,000. This time we're dividing by 1,000 because we have that negative. So if we look at it, 5 times 10 to the power of negative 1 would be the same as 5 divided by 10, which is 0.5. 5 times 10 to the power of negative 2 is 5 divided by 10 to the power of 2, which is 5 divided by 100, which is 0.05. And again, it'd be the same for 5 times 10 to the power of negative 3, which is 5 divided by 10 to the power of 3, which is the same as 0.005. So we're getting smaller and smaller now with our values. And if you can see a pattern forming, we can see that you're actually still got the same same levels of jumps. So this time we're just doing it in the opposite direction we did in the past. So let's look at 5 times 10 to the power of negative 1. So what we do is we take our decimal after our value and we move it backwards. How many jumps? So this time we have 1 jump, so we move it back once. So that's going to be 0.5. Always remember to put that 0 before the decimal place. Now, if we increase that to the power of negative 3, well, that's going to be 3 jumps now. And just like last time, when we had a jump that didn't have any numbers there, we put a 0 there. So you can see there now we've got 0.005. And again, we've got the same concept of 3 jumps. But obviously, we wouldn't use this for values this small. We would use it for values that are much, much smaller. So let's look at this one, for example. We've got 0.00000000195. So now we're looking at, we've got to do the exact same thing we did before. So we're looking for the first non-zero number. In this case, that's going to be 1, isn't it? So we're going to look at how many jumps we're going to have to do before we get past 1. So we jump across. So when we look at it, every single time we do a jump until we get to 1, you can see there we've made 1, 2, 3, 4, 5, 6, 7, 8 jumps. So that means that we're dealing with a factor of 10 to the power of negative 8, because remember, we're getting smaller now. When we're dealing with bigger numbers, it's going to be a positive factor. When we're dealing with smaller numbers, it's going to be a negative factor. So how we write that is 1.95 times 10 to the power of negative 8. Well, hopefully you enjoyed that. Please let me know if there is another math topic you'd like me to tackle, or if there's a very specific math problem you'd like me to solve, because I really do like hearing from everyone. I do like hearing the problems you have, and I just enjoy doing mathematics, and I do enjoy doing these videos. But always stay safe, be kind to one another, and I'll see you next time.